We're going to focus in now on the quadratic functions. Remember, a quadratic polynomial was a polynomial of degree 2. A quadratic function, then, is a polynomial function in which the polynomial is quadratic. This might seem like we're swapping topics, but it's going to turn out that we're not. Let's just take a minute and recognize some quadratic functions. Right here, f is quadratic, right? It's a polynomial of degree 2. So this is quadratic. The next example, g of x, right? We have an x squared minus 7. Again, this is a polynomial of degree 2. But notice that this is also a power function of degree 2. We just have the 1 power of x here. And so, right, if we had an equation involving this, for example, we could solve such an equation using the even root property. Now, h of x is definitely a power function of degree 2, but if we notice that x minus 5 squared, we could multiply that out. X minus 5 times another x minus 5. That's going to give us x squared minus 10x plus 25. So h of x is x squared minus 10x plus 25 plus 2, or x squared minus 10x plus 27. So even though at first glance it doesn't look like a polynomial, it looks like a power function, h is also a quadratic function. And it's pretty easy to see that we could do that same thing with any power function of degree 2. So power functions of degree 2 are also going to turn out to be quadratic. Now this next example is not a quadratic. It's not a polynomial at all. This is a radical function. Here we have a polynomial function in P, but its degree is 3. And then Q, we could multiply this out and get a polynomial, but it would have degree 4. So no, again, this polynomial, which is also a power function, has degree 4. So to be a quadratic, we need a polynomial of degree 2. If we multiply out a power function of degree 2, we also get a polynomial of degree 2. So those are also quadratic functions.